Okay, so first thing I want to notice is that my b here is telling me that the period is equal to the regular period divided by b. And so for a tangent function, the regular period is pi. So it should be pi divided by 1/6, which is equal to 6 pi. And so if that's the case, that means that my period is split down the middle at the line x equals 0. And so we'll have an asymptote here at 3 pi and an asymptote here at negative 3 pi. And then this 4 out front here is telling me that I have a vertical stretch of 4. And so what that means is that it's going to go through halfway there, that's at 1.5 pi. It's going to go through at 4. So it's doing this. And so the next asymptote, or so at 3 pi, then at 6 pi is where it's going to go through the x-axis again. And then at 9 pi is where we'll have another asymptote. And so it's going to look like this. And so that means that the vertical asymptotes within the period from 0 to 10 pi, so this is 0 all the way to 10 pi, there are two asymptotes will be at 3 pi and x equals 9 pi. So the next one says simplify the expression, show each of your steps in a clear order. Okay, so one thing that we can do on this and with this tangent and cosecant is let's start by getting it in terms of sine and cosine. So I know that tangent theta is equal to sine theta over cosine theta, and cosecant theta is 1 over sine theta. So what I can see is that sine theta divided by sine theta, that divides to make 1, and so I'm just left with 1 over cosine theta, which is equal to secant theta. So that's about as simple as we can get there. For the next one, I have cosine x plus sine x, the quantity squared, minus 2 cosine x sine x. So let's go ahead and square this binomial here. So I'll have, so when I square this, I'll have to FOIL it out. So that means cosine x plus sine x times cosine x plus sine x. So I need to make sure that I'm multiplying, that I'm factoring each of these things out. So when I do cosine x times cosine x, so that's cosine squared x, plus cosine times sine, plus sine times cosine, which is the same as cosine times sine, plus sine squared x. And then I have minus 2 cosine x sine x from this part here. So if I multiply that all out, that is what I get. And what I'm going to notice here is that this minus 2 cosine x sine x and this plus 1, so all of those cosine x sine x terms are going to add to 0. And so I'll be left with just cosine squared x plus sine squared x. And by the Pythagorean identity that we have, this is equal to 1. So the final answer there, in most simplified terms, is that that is equal to 1. So for the next one, it says, give an expression for sine theta. Given an expression for sine theta, find expressions for cosine tangent with theta in the first quadrant. So for the first quadrant, we're going to remember that in the first quadrant, cosine and tangent and sine are all going to be positive. So that first quadrant thing is going to tell us a little bit about the sign of each of these SIGN, whether it's positive or negative, of each of these trig functions. So I'm given here that x equals 4 sine theta, so I can divide that 4 over and I get sine theta is equal to x over 4. And I know that sine and cosine are related by that Pythagorean identity. So I know sine squared theta plus cosine squared theta equals 1. So instead of this sine squared, I'm going to replace it with what sine is equal to. So sine is equal to x over 4. So that's going to be x over 4 squared plus cosine squared theta equals 1. And then I can subtract that over and square root both sides. So I get cosine squared theta is equal to 1 minus And if I multiply that out, I'll get x squared over 16. And so then I can take the square root of both sides. So I get cosine theta is equal to the square root of 1 minus x squared over 16. And now when I square root both sides, I have a plus or minus. And I'm going to choose the plus or the minus based on what quadrant that I'm in. Now I know that cosine theta is positive in the first quadrant, so I'm going to select the positive sign for that square root. If I had been in a different quadrant, I might choose a negative sign depending on whether cosine is positive or negative in that quadrant. Now I need to find an expression for tangent theta. Well, I know that tangent theta is equal to sine theta divided by cosine theta. So I can just write that out, and I get that sine theta is x over 4, and that is over this thing, square root of 1 minus x squared minus 16. And so as I'm looking at this, I'm noticing that that is different from what is on the sheet here. So let's see if we can simplify a little bit more and get to it. So I'll have x over 4 square root of 1 minus x squared over 16. Now when I pull that 4 underneath the square root, I need to square it. So 4 squared is 16, so I can multiply 16 through underneath that square root. So I get square root of 16 minus, and when I multiply 16 by x squared over 16, I just get x squared. And so I can stop there. Next it says, use identities to find the exact values of cosine theta and sine theta, given that tangent theta is equal to 5 over 2, and theta is in, and what quadrant is that? That's the third quadrant. So pi is here, and 3 pi over 2. So it's in that third quadrant. And so in the third quadrant, cosine and sine are both negative. So let's see if we can use the identities to find that. So let's see. Okay. I need a quick way to get from tangent to sine and cosine. Well, I know that tangent theta is equal to sine theta over cosine theta. So that gives me that 5 halves is equal to sine theta over cosine theta, which tells me that sine theta is equal to 5 halves cosine theta. Okay, and now I know I can use another identity that sine squared plus cosine squared equals 1. And so I can plug that in for sine theta. So we get 5 halves cosine theta squared plus cosine squared theta equals 1. Then I can solve that for cosine squared theta. So let's keep going. And so I will have 25 fourths plus 4 fourths. So 29 fourths cosine squared theta, just combining like terms, equals 1. So I can multiply that over, and I get cosine squared theta is equal to 4 over 29. And then I can take the square root of that. Cosine theta is equal to the square root of 4 over 29. And now, since I'm in the third quadrant, I know that cosine is negative. So when I take that square root, I'm going to have to take the negative. I choose the negative out of the plus or minus to make that work. And then I get that sine theta is equal to 5 halves times that. So it should be negative 5 halves, square root of 4 over 29. So that reduces to negative 5 over square root of 29. And this reduces to negative 2 over square root of 29. So there's my sine and cosine values. All right, next I have if cosine t equals a over b, what is the exact value of cosine of negative t? Okay, and so I know that the cosine function has some symmetry. So if I think about drawing the cosine function, I can see that when I plug in a value t, if I plug in the value negative t, they have the same cosine value because I could see the y values are the same. So for cosine theta, so cosine of negative t is equal to cosine of t. So in other words, if cosine of t is a over b, what is cosine of negative t? It's still a over b. But for the sine function, it has a different kind of symmetry. So I can look at this function, and if I plug in some value t and some value negative t, what I see is I get, I don't get the exact same value, I get the negative of that value. So sine of negative t is equal to negative sine of t. And so that is the property of an odd function. So sine of negative t is equal to negative c over d. Next, find the exact values in radians of each of the following. So this is asking for us to find arc cosine of 0. So the question we're asking is, what angle has cosine value 0? And so I can look on my unit circle, I can look at my graph. If I look at my graph, I have a graph of cosine right up here, and I can see that cosine is equal to 0 when my angle is pi over 2. So you can look at that on your, again, your unit circle, or you could look at it on a graph. This is asking, when is sine equal to negative square root of 3 over 2? So what angle has sine value negative root 3 over 2? And so we have to be a little bit careful here because we need to know what the output of a sine inverse function is. So for sine inverse, it's going to output functions between negative pi over 2 and pi over 2. So if it's a negative square root of 3 over 2 is the sine value, that means the y coordinate is negative square root of 3 over 2. So it's going to be a 30 degree, pi over 6, so it's going to be negative pi over 6. So it'll be down in the fourth quadrant. When is tangent, for what angle is the tangent value square root of 3? And so so tangent is square root of 3 in the first quadrant. Well, it should be at pi over 6 or pi over 3. The solution manual has something, the solution, oh no, it doesn't. Okay, yeah, pi over 3, yes, okay. It should be at pi over 3. And why is that? Because at pi over 3, the sine is root 3 over 2, and the cosine is 1/2. And if I do root 3 over 2 over 1/2, I'll just get root 3. And then for this one, it's saying cosine inverse of cosine of negative 1/2. So this is a cosine value, which means that this guy is going to give me some angle from the output of a cosine function. And so I want to do cosine inverse of negative 1 over root 2. And so I want to find what is the cosine value of the angle that has cosine value negative 1 over root 2. And so let me write that out in words. So this is an angle. So it is saying what is the cosine value of, and then this in bit part is the angle that has cosine value negative 1 over root 2. And so the answer to that is negative 1 over root 2. So I didn't have to worry about any domain issues here, but I may have to in the next one.